Yeah, good evening all. Sorry, good afternoon all. So in yesterday's demo session, just I was briefing about what is ADF and the difference between this ADF and ADB, difference between ADF and Azure Data Lake, and the features of ADF, advantages and use cases of ADF, right? Generally, this Azure data engineering products, we have got Azure SQL DB, right? Azure SQL, Azure Data Lake, Azure Synapse Analytics, and Azure Data Factory. So ADF, it is a cloud-based ETL of Microsoft in Azure Cloud Platform, right? In Azure Cloud Platform. So it permits us to combine data from multiple data sources and reformat it into analytical models and save these models for querying data, for visualizations and reporting. Okay. So ADF, it is a data integration service. It is a data integration service means, what do you mean by data integration? So here, collection of data from one or more sources, collection of data from one or more sources. Later, it includes a process where the data may be transformed, data might be transformed, cleansed, merged, right? Finally, the whatever data is stored in a platform that deals with the type of analytics that we want to perform, right? So data integration, combining, collection of data, combining the data, transforming, cleaning, filtering, merging, grouping, all that. And also finally, what type of analytics that we want to perform on that and perform querying, visualizations, reporting, right? This process can be done in this process can be automated by ADF in an arrangement known as extract, transform, and load, ETL, right? ETL. Extract means in this extraction process, the data engineers define the data and its source. Means define data by using the files or database query or Azure blob storage, right? Yes. Identifying the source details. For my ETL pipeline, data source can be Azure SQL, target can be a data lake, right? Or Synapse. Yes. As a ADF developer, we need to interact with other products. We need to interact with other products, right? So generally, extracting transformation. So as a ADF developer, we need to interact with other products such as Azure Databricks. We need to interact, okay. Cosmos, for example, Azure Cosmos DB. Azure Streaming. Azure Key Vault, right? So as a ADF developer, we need to interact with other products like Azure Databricks, Cosmos DB, Azure Streaming, Azure Key Vault, right? Identifying, okay, we need to define data and also identifying the source. So this previous, this four and this four, these four and these four, these four, right? These are the regular products. These are the regular products of Azure Data Engineering. Is my voice clear to all? Once again, can anyone please confirm once, right? These are the regular products of Azure Data Engineering, right? So generally, I was talking about this data engineering products, right? So you can just not only these are the main things, right? Here I discussed Azure Data Engineering products. Apart from this Azure SQL, these things, right? Right. Azure Data Engineering, Azure SQL, Azure Data Lake, Azure Synapse, Azure Data Factory, Azure Databricks, Azure Cosmos DB, Azure Streaming, and Azure Key Vault. So as a ADF developer, right, we need to interact with these products, Azure Cosmos DB, Streaming, and Key Vault. For example, observe this. ETL, ETL. Generally, it is ETL. Generally, it is ETL. But our working model is, working style is ELT, ELT. Observe here, generally it is ETL, but our working model is ELT. Extract, load, transform. Observe this, ETL, ETL. Generally, ETL technologies are there, right? Good for, they are good for small data. Good for small data. ELT, if I talk about this ELT, extracting, loading, and transformations, right? Yes. These are good for huge data. They are good for huge data, means huge data in the sense in terabytes of data, in terabytes or petabytes. Petabytes. Understand this, ETL good for small and ELT is good for huge data. Yes. So totally I said about 8 data engineering products, right? So we need to, as an IDF developer, we need to interact with these products. One second. Okay. ETL good for small data, ELT good for huge data. Generally, it is ETL, but our working model is ELT. And transform means data transforming. It includes data transformations includes operations such as combining, splitting, adding, deriving, removing, filtering, grouping, sorting, merging, but we map the fields between the data source and destination, between the source and the destination. I said the source can be anything, right? In our example, data source can be Azure SQL, target can be a data lake. So mapping the fields between these data. Load, during load, many Azure destinations, right? Another destination can take data formatted as a file format, JSON or BORO. ADF provides approximately 100 enterprise connectors in the resources. I was just briefing you about those things, right? Yes. The aim of ADF is to fetch data from one or more data sources and convert them into a format that we process, right? Yes. The main aim of ADF is to fetch data from one or more data sources and convert into the process, right? The data might contain some noise that we need to filter out, right? Yes. ADF connectors enables us to pull interesting data and remove the rest. Yes, ADF connectors enables to pull interesting data and remove the rest. ADF allows to create a data-driven pipelines. A pipe is any data operation, right? Generally, a pipe is any data operations. One, the output of one will be the input. And here for orchestration, data movement, and a transformation of data. Okay, here you need to understand one more thing. Orchestration. Here, generally, whenever you say about ADF, we need to discuss about what is meant by orchestration. Okay, sometimes ADF will instruct another service. It will instruct another service to execute the actual work, Sometimes ADF will instruct another service to execute the actual work on its behalf. Right? Yes. Such as Databricks. Such as Databricks. ADF. ADF involves in the execution of the query, in the execution of the query, and then prepares the pipelines, and then prepare pipelines to move the data, to the destination, right? Yes. To move the data to the destination, right? Yes. For example, sensors, IoT, logs. Observe this: sensors, logs, any kind of media, files, business apps, custom apps, from all this, right? From all this, observe this, from all this, from this IoT or from the sensors. So from the sensors, IoTs, logs, media, files, from all this, right? Yes. ADF, ADF, from all this, right? It's just going to take the data from the different data sources from the sensors, IoT, logs, files, media. All this data will be in unstructured format. Data will be in unstructured format. So here, what is performing here in this step? Data ingestion, data ingestion. Later, store. Azure data lake. Azure data lake. Next, preparation and training. Okay, next, preparation and training. By whom? Preparation and training. Who does this preparation and training? ADB. ADB, Azure Databricks. After this, you can perform. Just I was saying right here, what you can do later, right? Querying, visualizing, and reporting. Understand here, you can take different data sources like even on-premises data or this cloud systems, right? You can take data from this ADF and store it. Azure data like preparation and training by Azure Databricks. Later, querying, visualizing, and reporting. So in this way, right, even ADF has got hundreds of connectors, I was saying, right? Like Salesforce, ServiceNow, SaaS, Dynamics, Azure S3, SAP HANA, HDFS, or even Netija, Azure SQL DB, Teradata, right? In this way, we have got many things, right? It's connectors for this. Okay, main difference between this ADF and ADB is for data integration, is for big data analytics and executing data workflows and ETL processes. Big data processing and analytics, right? Data transformation using data flows and mapping. Here, advanced transformations using Spark. And here, scales through integration with other data Azure services. Here, highly scalable with built-in clusters, right? Between Spark clusters. And here, okay, It is a cloud or DBMS database of Microsoft in Azure. It is okay. I'll just come back to this Azure data lake, right? What is Azure SQL, right? It is for OLTP operations. It is for OLTP operations, right? Yes. Online transactional processing. What is that? Online transactional processing, right? Generally, what OLTP will do? OLTP will do, right? OLTP systems. Generally, these OLTP systems, right? They captures end users transactions. End user transactions, right? Yes. Means means whenever transactions performed, whenever transactions performed should be recorded in the database. Means whenever transactions are performed should be recorded in the so means whenever transactions are performed should be recorded in the database. Example, right? Yes. For example, banking example, if we take banking example, withdrawing, you are withdrawing, okay, or you are depositing or transferring money, right? Yes. From one account to another. Observe, whenever withdrawing, depositing, transferring money from one account to another, right? All these transactions, whatever all these transactions has to be recorded, right? All these transactions should be saved or recorded into OLTP systems, For OLTP, generally, for online transactional processing, for OLTP, we have two systems. We have two types of systems, right? We have two types of systems. First one, regular RDBMS, regular or relational database management system. And secondly, we have got NoSQL databases. Secondly, we have got NoSQL databases. NoSQL, right? Yes. So whatever that Cosmos DB comes in NoSQL database. Comes in what? NoSQL database. Okay, try to understand this, where we are going to use this Azure SQL and what purpose it is used and why we go for data lake, Databricks, the ADF. You need to clearly understand. Generally, if we talk about this, okay, main difference between RDBMS, try to understand RDBMS, difference between RDBMS and Azure SQL. Azure SQL, right? Yes. First, RDBMS. Let me discuss about RDBMS. On-premises database. What is it? On-premises. These are on-premises databases. Regular RDBMS examples, right? Oracle, MySQL, DB2, SQL Server, right? Fine. RDBMS, right? On-premises databases. Means we need to set up, generally we need to set up our own hardware infrastructure. Understand here, on-premises databases means we need to set up our own hardware infrastructure. And also we need to, again, on top of that, OS installation, right? Again, apart from this, purchasing, generally installing, okay, purchasing database license. Next, what you need to do next? Installation of database server. Next, designing, what you will do next? In generally, whatever database you are using, right? Designing database objects. All this we need to perform. To maintain all the above, one more thing, to maintain all the above, we require separate teams. Generally, we require separate teams. For example, what are the teams? Like a hardware team is required. Operating system team is required. Networking team is required. Security team is required. And finally, right, database administrators. So these many. But we talk of in Azure SQL. Right? We talk about this Azure SQL now. Up to now, RDBMS, all these are required. But if we talk about this Azure SQL, in Azure SQL, no need to maintain any infrastructure for it. In Azure SQL, no need to maintain, right, any infrastructure for it. No need of licenses. That in Azure SQL, everything in cloud premises. So no need to maintain any infrastructure, right? No need of licenses, right? Generally, license validity for limited period. Generally, if you're in on premises, right, it will be for limited. Again, you need to keep on renewal. But here, everything in cloud environment. Just to create, what you do, just to create Azure SQL, just create Azure SQL, right? Instance. Just to create Azure SQL instance and we can work your applications. Just to create a Azure SQL instance and your applications can start writing or reading. And perform any CRUD operations CRUD, creating, reading, updating, and deleting operations right here. Here, all those are not required. All the headaches are not required here. In the case of on-premises, we need to maintain everything, right? And one more clearly understand this Azure SQL. The purpose, right? Yes, is for OLTP. Azure SQL purpose, just observe. Purpose is for OLTP, but not for data warehouse, not for DWH. Generally, yes. Generally, what is the problem we see with this OLTP systems? Problem with OLTP, just observe this problem with OLTP systems, right? Yes. First one, limited capacity, yes. Limited capacity means limited capacity in the sense, even if you say limited storage, you can say, or less process speed, right? Generally, problem with OLTP systems, right? Limited storage and less process speed. They maintain, observe this, they maintain only limited data. They maintain only limited data. That too, recent data. They maintain only recent data into OLTP systems, They maintain only limited data into OLTP. See, you know, those people who has got knowledge on this ETL, right? SED type 2, SED slowly changing dimensions, right? So if you see recent data, they'll be maintaining the recent data, right? Into OLTP systems means organization use different OLTP systems. Okay. Talking about this organizations, they use different OLTP systems. They use different OLTP systems. In each OLTP systems, right? In each OLTP systems, different databases will be there, right? Yes. Organizations, they are going to use different OLTP systems in each OLTP. In each OLTP system, so just different databases will be there. For example, right? An organization, right? For think an organization has a history, right? As a history of 20 years. An organization has a history of 20 years. Observe this example. All 20 years data, you cannot keep, right? You cannot keep in OLTP systems. You cannot keep in OLTP. Why? Because of less storage. Because of less storage. Understand this drawbacks. An organization has a history of 20 years. You cannot, all 20 years data you cannot keep in OLTP because of less storage. Here, just here, we maintain only last 1 year data. Last 1 year data. That is what? That is what? Recent data. What do you mean by recent? That is what? Recent data. We maintaining only last 1 year data. That is what? Recent data. Because of a problem. What is that? Limited storage. Limited storage. Example, right? One. Generally, bank provides, if you talk about the bank provides, right? If you ask a statement for a bank provides statement for 1 year only. 1 year only. Recent data. What is that? That is what we call like recent data. For example, if you are the customer, if you are the bank customer, right? Yes. From last 20 years. From last 20 years, since from the beginning of, yes, from last 20 years, right? Yes. If you ask for okay. You ask a statement, if you ask statement for last 20 years, for last 20 years, right? Yes. Then data not available. Data not available in their OLTP systems. OLTP systems. Where they are available, there are where they are available, that is available in historical databases. They are available in historical databases. Historical databases called as data warehouse. Data warehouses, right? Yes. Understand here problem with the OLTP systems at limited storage and less, even the processing speed also is going to be less, right? As organization use OLTP systems, different databases will be used and they maintain only the recent data. And that too, how much data? How much data they keep in OLTP? How much data they keep in OLTP? It depends on what? It depends on transactional frequency. It depends on the transactional frequency. Last 6 months data, last 1 year data, last 2 year data depends on their transactional frequency. They decide, right, how much to keep. They decide how much to keep, right? They decide how much to keep in OLTP systems. In OLTP systems. Either you want last 1 month or 6 months or 1 year. 1 year. So generally, if we talk about the current, if we talk about this e-commerce systems like Flipkart, they are generating nearly 20 TB per day, right? So how much days data is to be stored, right? And maximum, how much data, how many days or how many months, right? Data has to be kept to be stored. Even if you talk about the Facebook, it's generating nearly 140 terabytes per day, right? Approximately, right? So no, so actually, if you talk about we are designation data engineers this today, like if you go back like 15 years, 20 years, the data was too small. The data is too small, right? But now we are designating some data engineers, right, to work with this data to extract the data from the different sources, right? But if you see 20 years back, there were no data engineers. The data is too small in MBs or in GBs, below GBs, right? And that too today the data engineers, cloud data engineers, right? For example, if you take example of a Facebook, in 2013, if you take in 2012, or if we talk about 2012, right? Yes, it was generating nearly, it was generating like nearly 120 TBs, 120 TBs per day. But if you talk about in 12 years later, in 2024, approximately, right? Yes, approximately it was generating 4 petabytes. So millions and trillions of users, they are posting many messages, videos, those things, but huge data is generating. So generally this huge data, right, 4 petabytes per day, right? Where to store? That is one thing. How to process it? Where to store and how to process? Okay. So for that, what is this Azure SQL, everything in the cloud premises? And if we talk about this Azure SQL, right? The cloud RDP. So we go for cloud RDP mesh databases. We go for cloud RDBMS. Okay, I'll discuss about these things, right? Yes. So we have got every cloud has its benefit, right? For example, if we talk every cloud, why I prefer Azure only? Why not like AWS, GCP, right? But Azure, it is cheaper in cost, even for running my data process, right? Every cloud is good, but here as compared to that, Azure has got a cheaper in cost and running. Okay. So for example, if you talk about any other applications, right? Any applications, even if you talk about LinkedIn or Facebook or WhatsApp, right? They're generating huge data, like petabytes of data, right? Yes. One second. We have got some specialized databases. We have got some specialized databases like Teradata, Netezza, Vertica for data warehouse purpose, right? If you are keeping these things as the backend to this, right? for Facebook or this for LinkedIn, right? Even they cannot handle 1 hour data. Forget about the Oracle and MySQL, right? Or forget about that Oracle and MySQL. So, right? So, to support latest, to support latest huge data volumes, right? So once again, I'm saying Azure SQL is for OLTP, not for data warehouse, right? To support latest huge data volumes, we go for, or we have data lake. We have data lake. Yes. We have Azure data lake. Now, this data lake, right, is inspired from Hadoop. It is inspired from Hadoop, HDFS. It is inspired from Hadoop HDFS, right? Generally, DFS advantages, distributed file systems advantages. What are the advantages, right? Mainly, huge volumes of data storage. Observe this, huge volumes of data storage. Huge volumes of data storage, right? Means unlimited data storage you can possible, right? Supports parallel processing. Right? To support parallel processing. So data lake same as HDFS, Hadoop distributed file system. Hadoop distributed file system, right? Hadoop doesn't use any databases for storing its data, but it uses a kind of file system called Hadoop distributed file system. It is an unlimited data storage. And you already know, like, why databases won't support means databases, there is a limit on this. They can store only limited data. Okay, same like HDFS. Same HDFS behavior, right? Hadoop distributed file system, storing huge data, unlimited data. But HDFS, right? What is HDFS? Hadoop distributed file system on premises. It is for on premises. Own infrastructure required. Own infrastructure required. Example, right? 1 petabyte regularly. Assume that a huge data inflow is there. There is a huge data inflow is there. 1 petabyte regularly storing and processing. 1 petabyte regularly storing and processing. How much cluster required? How much cluster is required for this? How much cluster is required? So here we need to maintain. So here we need to maintain biggest data centers. Excuse me. Here we need to maintain big data centers, right? Yes. So it is complex to maintain. So it is complex to maintain. So it is complex to maintain this, right? Yes. For example, if you are maintaining, if you are maintaining, if data increased from 1 petabyte to 5 petabytes, then high complex, very complex, right? Very complex to maintain the cluster. And also on premises, right? We need to maintain a lot of teams required, lot of installations required. Okay. So if data increased from 1 petabyte to 5 petabytes, so it's much. So now up to now previously I discussed about Azure SQL. Now Azure Data Lake. Azure Data Lake. Observe. I want some distributed file system. With unlimited data storage. Some distributed file system with unlimited data storage. I want in cloud. Right? I want in cloud. That is data lake. Understand here? Some distributed file system with unlimited data storage I want in cloud. That is what data lake. In the case of, you may ask, already we have got Hadoop for huge data storage, right? HDFS on premises, right? DFS, distributed file. If company is maintaining that, right? Okay, it's fine. Azure Data Lake. It is what? Cloud DFS. Cloud DFS. So generally what this Azure Data Lakes, they offer benefits is unlimited data storage, supports all varieties of data, structured, semi-structured, unstructured, supports all formats of data, right? Yes. So everything is going to be saved or recorded, right, within these things. So understood. Azure Data Lake, distributed file system with unlimited data storage I want in the cloud. But what is Azure SQL, right? It is a cloud or DBMS database of Microsoft in Azure. And coming to this ADF, right? ADF, it's a cloud-based ETL of Microsoft in Azure Cloud Platform. ADF, Azure Data Factory, is cloud-based ETL, and this Azure SQL is Azure SQL, right? Yes. Cloud or DBMS, data lake, distributed file system with unlimited storage, want in cloud, that is what? Data lake. Yes. Databricks for data engineering, right? For big data and for Spark applications, right? Data. Not only this, we have what other things, right? I'll be briefing you about all these things. I'll give total picture, total idea about all this before going with the actual, right? Yes. So everything step by step, I'll be explaining you. Everything you'll be able to understand, right? Yes. So you can just check the course content in this, right? You can see in the chart. You can see in the chart, right? Yes. The course content demo link is given, course content, and that yesterday video is given, right? So the course fee is 6,000, right? Yes. If you, okay, 1 second, right? Offerings. You'll be getting that every session video. Live recorded with live video, right? Live recorded video means whatever the class session, right? Even if you're absent for a particular session, right? You can go to the video and attend the session, live recorded video. Soft copy of the class notes, even step by step, everything I'll be explaining you, right? So wherever required, I'll ask you to do parallelly along with me. Yes. Wherever any complex tasks, right? I'll ask you to do parallel along. Yes. Soft copy of notes. The WhatsApp group. Interview questions. Okay. Fine. All the sessions will be interactive, right? Anywhere, if you got any query, you can unmute yourself and you can ask your query, right? So the videos you will be getting to your Google Drives from the next Saturday, right? The link will be changing. You're supposed to get enrolled. So after once you got enrolled, right, don't forget to share the screenshot of your payment to this DURGASOFT online team. The mail ID is provided in the chart. Can you see in that a big message is given? Their contact details they have provided, right? They have provided their contact details. And that even the payment details, the Google Pay or whatever the other details, you go through it, right? Yes, you'll be getting the videos to your Google Drive, notes to your mails, and a WhatsApp. You'll be added to the WhatsApp group. So next Saturday, the link will be changing. From next Saturday, you'll be getting the videos to Google Drive, notes to your mails, and clear notes. Whatever notes, everything will be 100% understandable, right? WhatsApp group, you will be added to the WhatsApp, right? Yes. So that so from next week, right? It's just 2 to 4, right? 2 p.m. to 4 p.m. 2 p.m. to 4 p.m. right? So if you got any doubt and any topic, if you have missed out, and if I start any new batches in the coming days, if you have missed any session, if you want to attend a particular topic in any other new batch also, if you have missed it or anything, right? You can attend in that new batch also, right? If any topic is missed. Anyhow, you will be getting the video of each and every session. So 2 p.m. to 4 p.m. will be the timing of the session, right? Yes. Okay. Fine. This is just introductory class of this ADF. Just I was briefing you about this. So next week from 2 o'clock to 4 o'clock. So get enrolled. You will be getting the new link to your mails, right? Fine. So I'm stopping for now, right? We'll continue in the next Saturday, right? More discussion of this, right?
Sir, I have one question.
Yes, go ahead.
Yeah, actually, this session is for the Azure Data Factory, right?
Yes.
So, what is the difference between Azure Data Engineering and this Azure Data Factory? I mean, is this part of the Azure Data Engineering or how? I mean, how we can differentiate that?
So you'll be getting all Azure Data Engineering, right? You'll be getting all these things in brief. Azure Data Engineering products, I said, right? So here our concentration will be on Azure Data Factory, ADF, Azure Data Engineering products. So Azure Data Factory. So yes, this one, ADF. But still I provide you the knowledge about these things, right? I'll provide you the knowledge of this SQL data lake and data factory. Yes. Okay.
Sir,
Okay. So yes, even in the future, right? I'll be having batches about this ADB, Azure Databricks, PySpark. Already PySpark batches I'm running, right? Many PySpark batches I'm running, big data and PySpark batches. In the future, also Databricks and even the other total data engineering courses are there, right? So people, if you already got enrolled with ADF, right? So they'll be given some discounts and you can get added. You can also attend the other sessions, right? Yes. So
Sir,
no,
what is the discount for other batches, PySpark and full Python full stack students?
so yes, already, okay, you can talk with the team, right? So people who are already doing PySpark, who are attending PySpark, right, there is a discount for them, right? You can talk with the team, right? You can just give a call for them. Okay,
Okay, sir. Thank you.
fine. So people who are already doing PySpark, right, attending PySpark or otherwise big data analytics, right? You can check with the team, right? Or otherwise the online team. Okay, fine. So here also everything, whatever I discuss, everything will be understandable, right? Everything will be understand step by step, everything will be discussed, and even the practical part also, everything. But only thing is just to check with that everything, whatever I do, right? Try to do the practicals, completed that before the next session for the better understanding, right? So in the future, not only this, all the products that I'll be starting the batches on this, even data engineering, data bricks, all this, right? Fine. So as of now, ADF, right? Many people are attending PySpark and this big data, right? Hadoop. Okay, fine. Any other query, right? Any other queries? Okay, fine. So next week from 2 to 4, right? Yes, we'll go with this. Right? Thank you all for your time. Thank you. Meet you on next Saturday at 2 p.m. Right? Fine.
Thank you.